In Part 7 of the Unit 1 notes, we will be covering operations with significant figures. First, we will start with addition and subtraction. So there are going to be two separate sets of rules within this notes video. Addition, subtraction, and then multiplication and division, we're doing something different. When adding or subtracting measurements, the answer must have the same number of digits to the right of the decimal as there are in the measurement having the fewest digits to the right of the decimal. You're actually not counting significant figures at all for addition subtraction, which I know might seem a little counterintuitive here. We're just looking at places after the decimal. So let's look at example 1. We have 25.1 and 2.03. First thing you have to do is do the math. So we're going to add those normally, and we have 27.13 grams. Now looking at my original two values, this first number had one place after the decimal, and this one had two. When we're adding numbers like this, we can only write out our answer based on whichever of those measurements was the least precise, which would be this, one after the decimal. So I look one past that. I look to the 3. And then I have to determine if that 3 is large enough to round up my 1. And our rule for this is it has to be 5 or higher. So since 3 is not enough to round up the 1, it simply gets cut off. And we end up with 27.1 as our final answer. In our next example here, we're doing the same thing. We're doing addition, except this time we're given numbers with scientific notation. So we're adding these two skills together. Remember, if we are adding scientific notation without the use of a calculator, our exponents have to match. So here I had to the 4th power and to the 5th. So what I did was I slid my decimal one spot to the left to make this 0.42 times 10 to the 5th power. Now that my exponents match on both sides, I can do the math. So I have 0.42 plus 7.9, and I end up with 8.32. And now the exponent can just carry through. So 8.32 times 10 to the 5th. Now I'm going to do the significant figure part of this. Looking at my original values here, this was one place after the decimal and one place after the decimal. That means my final answer must also be one place after the decimal. So I look to the 2. It is not enough to round up the 3, so it gets cut off. So my final answer would be 8.3 times 10 to the 5th. All right, so at this point, you should be writing out these examples in your notebook, and we're going to work through these checkpoint questions together. All right, so for our first example here, we have 45.662 and 24.0. So we can either plug that into the calculator or write it out longhand. We end up with 69.662 seconds, and that's our long answer. Now, looking at my original numbers here, this had 3 places after decimal, and I'm just going to abbreviate that PAD. So 3 places after decimal, and this had 1 place after decimal. So that means I need to round this to 1 place after the decimal. I can keep this 6. So I look to the next 6 to see if that's enough to round it up, and this time it is. So 69.7 seconds. For number 2, we're going to subtract these two values, and my long answer is 2.8297 joules. But if I look back to my original numbers, this had 2 places after decimal, and this had 4 places after decimal. I have to round based on the least precise, so 2. That means I can keep the 8, I can keep the 2, but that's as far as I can go. So I go 1 past, it looks like the 9 is going to round up that 2. So I end up with 2.83 joules. All right, for our next example, now we have some scientific notation we have to deal with. So we have to make sure that the exponents are the same first. Since this is a -2 and this is a -3, it would be easier to make them both the same as the larger exponent, that's the -2. So I'm going to change this to 0.5 times 10 to the -2nd. So all I'm doing is taking this decimal, I'm going one spot to the left. Because I make this smaller, my exponent gets bigger. So now they're going to match. So I have 2.98 minus 0.5. That's pretty simple. We have 2.48 times 10 to the negative second power, and our unit here is grams. All right, now we have to do the rounding part for significant figures. Based on my original values here, I had 2 places after the decimal and 0 places after the decimal. This was a whole number. So I'm going to have to round this to a whole number too. The 4 is not enough to round up to 2. So this is going to be 2 times 10 to the negative second grams. Now, a common misconception that typically confuses students, I will have some students that will round this 8 up to the 4 to make it a 5, and then they round the 5 up to the 2, and then they end up with 3. So that's kind of a waterfall type of effect where you're going one to the next to the next. You're not allowed to go that far down the line. So if I can keep the ones place, you're only allowed to look one place to the right. So it doesn't matter any numbers that come further down from there. All right, for our final example on this slide, we have to the 7th and to the 6th power. So again, we need to slide our decimal in order to make these match. So I'm going to change this to 0.67 times 10 to the 7th power kilometers. And now I can add these two numbers. So when I add 2.52 and 0.67, I end up with 3.19 times 10 to the 7th kilometers. My original values, I had 2 after the decimal or 1 after the decimal. So I can only keep 1. This is the place I'm keeping, so let's look one spot to the right. That 9 is enough to round up the 1. So 3.2 times 10 to the 7th power kilometers. So that is how we are going to be rounding for addition subtraction with sig figs. Next up, a separate set of rules for multiplication and division. When multiplying or dividing measurements, the answer must have the same number of significant figures as the measurement with the fewest significant figures. So this time we're actually going to be using that counting skill that we had on the previous video. So in this example here, I have 3.05 and 8.4700. So you just plug into the calculator, and this is the long answer. Counting significant figures, this one has 3. It has a sandwich in the middle for that 0, or if you're using the Atlantic Pacific rule, a decimal is present, which means you start counting from the Pacific side. 1, 2, 3. Over here, this is going to have 5 significant figures. If you're using the rules, these are right end zeros, so those count. Or you could say decimal is present, count from the Pacific side, 1, 2, 3, 4, 5. So between 3 sig figs and 5 sig figs, 3 is less. We're always going based on the least precise, whether you're doing addition, subtraction, or multiplication, division. So I say, okay, this 0 is not significant, but the 3, 6, and 0 are. So that's as much as I'm allowed to keep. This 0 is not enough to round up that 0. So I end up with 0.360 meters. My unit here, I had meters squared divided by meters. So one of the meters cancels out, which is why I ended up with meters here. All right, for the second example, we have 2.44 times 4.5, which is 10.98. Our exponents are going to add together because we're multiplying. So a -3 plus a -4 is a -7. I have to slide my decimal one spot to the left to make it proper notation. I end up with 1.098 times 10 to the -6th power centimeters squared, because it's centimeters times centimeters. Now from here, I have to round for significant figures. This value had 2, this value had 3, and those are easy to determine because there's no zeros, so there's no tricks here. All right, so since I have 2 significant figures, I can keep the 1 and the 0. I look one beyond that. The 9 is going to round up to 0. 1.1 times 10 to the -6th centimeters squared. All right, so now let's go through a set of checkpoint questions for our multiplication and division rule. First up, we have 3.550 nanometers, and we're multiplying by 0.0065 nanometers. Now this will be pretty hard to do in your head, so you plug this part into your calculator, get your long answer. It is 0.023075 nanometers squared. So that's just the long answer the calculator would give you. I'm going to go back and count significant figures. This one has 4 significant figures. The 0 on the end counts. It's a right end 0 with a decimal. And this one has 2 significant figures. These are leading zeros that are just placeholders. They don't count. So that means I can keep 2 sig figs. This 0 is not significant because it's leading. This 0 is not significant, still leading. 1, 2. So that's as much as I'm allowed to keep. This 0 is not enough to round up to 3. So 0.023 nanometers squared would be my final answer. Next up, number 2. I'm going to plug this into our calculator. We end up with 0.038944287. So a very long number here. And that's going to be grams per centimeter cubed. So when our units don't cancel out like this, both of them will be included within your final answer. All right, let's look at sig figs. We have 1, 2, 3, 4, 5. All 5 of these are significant. There are no zeros there. For this one, this is a right end 0, so it does not count. So 2 significant figures. These 2 zeros are placeholders. 3, 8 are my 2 significant figures. The 9 would round up the 8. So I end up with 0.039 grams per centimeter cubed. All right, next up, we have some scientific notation to deal with here. So we are going to divide the 2 coefficients. 4.5 divided by 9 is a half, or 0.5. So we have 0.5. And then we are going to have times 10. This is a negative 5. We're subtracting because it's division. So negative 5 minus a negative 7. It's positive 2. We have to fix the scientific notation here. So that's going to be 5.0. If I slide this over one spot, make this bigger by 1, this gets smaller by 1. So times 10 to the first power. And now we can finally deal with the significant figures part. Here, these are right end zeros with a decimal, so 4 significant figures. These are right end zeros with a decimal, so 3 significant figures. Right here, 5.0, this does not have enough significant figures. It only has 2. So we haven't run into this problem yet. The only way to keep this number the same exact value while increasing the number of significant figures is to add another 0 after that decimal. It's still going to be exactly 5, but because of this decimal, that 0 is going to count as significant. So that's times 10 to the first power, and let's see what unit we have here. Centimeters cubed divided by centimeters, so that's going to be centimeters squared. All right, for our final checkpoint question, we have 2.98. We're multiplying by 8.7, so that's going to come out to 25.926, and then we're going to add our exponents. So a 4 plus a negative 9, negative 5. We're going to slide that decimal one spot to the left to make it 2.5926 times 10 to the negative 4. This has 3 significant figures. There's no zeros, so all 3 of them count. This one has 2. So we're going to round this for 2 sig figs. That means I can keep the 2, I can keep the 5, the 9 is going to round up to 5. So 2.6 times 10 to the negative 4th power. Meters times meters is meters squared. That brings us to the end of part 8 for our Unit 1 notes. Sorry, part 7. When we come back for part 8, we will be finishing things up with 1- and 2-step metric conversions.